Hello, and welcome back to my Blind 75 Python Solution Series. Today, we are going to be taking a closer look at LeetCode question 152, also known as the maximum product subarray. This is a medium level question, and today's solution will be in O of n time and O of 1 space, and is about 96 to 99% faster than the other Python submissions. I got both when I ran the solution for whatever reason, but it's really fast compared to other answers. Before we read through the problem, please take the time now to subscribe to my channel and like this video. It really helps me out and is greatly appreciated. Now that you've done that, let's read through the problem. So for the problem, we have given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return the product. And so the subarray is a contiguous subsequence of the array. So what that means, and we've talked about it before in some of the other videos, but as we go along through, you can't skip over any values for it to continue to be a part of our subarray maximum. When we look at this problem right here, this example 1, when we look through this, if we go through the values and we see what is the biggest one, we're going to look at here, 2 and 3. It's going to be 6. If we go 2, 3, negative 2, it's going to be a negative number. 2, 3, negative 2, 4, also a negative number. 3 and negative 2, it's going to be a negative number. Negative 2 and 4, negative number. And that pretty much goes all the way through our array. And how we're going to be solving this problem is we're going to be looking at this the same way as we looked at the last problem that we did, which was the maximum subarray problem. And we will once again be solving this problem using dynamic programming, which simply put is breaking the problem into subproblems, solving these subproblems, storing the solutions that match our criteria, and then returning the solution at the end. And what dynamic programming allows for us to do is save computation time by using a technique called memoization. And what memoization is, it allows you to store the results of repeated function calls that are made with the same parameters. So instead of repeating calculations, we just store the previous values and then compare those to our new values to get our result. So let's take a closer look at the problem. Right here, we have the nums array, which is just the same as we had above in our example, and that's the array that we're going to go through. And we have these 3 variables, which is current max, current min, and max product. And I just shortened it to max prod. And these variables, what we're going to set them at the start is going to be this first value right here. So we're going to set them all to 2. And the reason that we're going to do that is because then this is going to allow us to set our end value when we do our loop to 3 instead, which is our index 1. So we don't have to start at the very beginning. It's going to lead to less loop throughs of the problem by starting there. And I'll explain that a little bit more when I go through the code breakdown, but just know that that just simplifies the problem and speeds up our time a little bit. So next, we're going to go through the steps. So for a dynamic programming problem, there's going to be steps involved because we're going to do the same steps for each loop. And that's going to allow us to save our new values. What we're going to do for step 1 is we're going to set our current min to take the minimum of our current value versus the current value times current min, and then versus the current value and current max. So it sounds complicated, but it'll make more sense when we code it up as well. But just know that that's the calculation we're going to be doing. We're going to find the minimum value of that. Now for step 2, you're going to do the same thing as before, but all you're going to change is you're going to find the maximum value instead, and then you're going to set that equal to the current maximum. And then lastly, all we're going to do at the end is we're going to set our max prod value equal to the maximum of the max prod that we currently have versus the current max. And that's all we're going to do. So just a couple lines of code there when we code it up. Let's go through the problem. So for our first loop, as I said before, we're going to be starting at this index 1 value. And so how we're going to do this is just like our problem says, is we're going to set a minimum with all these values and the maximum with all these. So for the current min, how that's going to look is we're going to take our n, which is 3, and we're going to set it to n times our current minimum value, which is going to be 2, and then n times our current maximum value, which is also currently 2. So max and min are 2. And then we're going to find the minimum value of this. So the minimum value of these 3 values is going to be equal to 3. Now, same thing, it's going to be the same exact calculation as above. The only difference is we're going to be instead finding the maximum, which is going to be 6. And then we're going to compare 2 versus 6, and that's going to equal 6. So these 3 values are going to change, and they're going to be 3, 6, and 6. Now we're going to do our second loop through, and n is going to move over here. And then we're going to do the same thing as we did before. This is going to be, our first value is going to be n, which is going to be -2. And then we're going to take n times our min value, which is 3. So times 3. And then our n times our maximum value, which is equal to 6. And then we're going to find the min of that, which is going to be -12. Same thing as above, but we're just going to find the max. So take all of those values just like we did before, but the max instead is going to be -2. And so we can change these values. Oh wait, and we also make sure you know that we got to take that old maximum value, which was 6, versus -2. And of course, 6 is bigger, so our max prod still stays as 6. Those 2 values, our minimum value is going to be -12. Our maximum value is going to be -2. And then we go to the next number in our loop. Last time, we're going to take n, which is going to be 4. And then we're going to do 4 times our minimum value, which was -12. And then we're going to do 4 times our maximum value, which is -2. And then our minimum of this is going to be -48. So take all the same as above, 4 times -12, 4 times -2. What's the maximum of this? It's going to be 4. And then max prod versus current. So it's going to be 6 versus 4. And that's going to equal 6. And then our value that we're going to return at the end. So we're going to return our value of 6. And then we're done. And that's the answer. So I hope that helped you out. Now let's go take a look at VS Code and code this up. All right, so let's go ahead and code this up. So first what we're going to do is we're going to create our function. So max product sub with our array equal to nums. And we first need to create our variables in order to store the values we want to change in our subproblems. And what we're going to do is we're going to set these variables equal to the first value in the array, like I said before, because that will not only allow for the correct return value if our array only had one value, but it also allows us to start our loop from index 1 instead of index 0, which saves us some time. So we can write our variables like this: current max, current min, and then max prod. And we're going to set all of these equal to nums 0. And there's a couple different ways to write this, but I like to write it like this. And then the next line, we're going to want to loop through our array starting at index 1, so for n in nums I to the end, or 1 to the end. For this next line, there's a few different names, including parallel assignment, tuple unpacking, iterable unpacking, and multiple assignment. If you hear any of these terms, it's all the same thing. What it means is when you use this technique, you are creating a tuple or an ordered sequence of values that aren't mutable. And I'll explain a little bit more of why we do this in a second. Let's first write it down. So current max equal to the min of n times current min, n times current max. And then same value here, just copy and paste, and we're instead going to get rid of that and put max. Oops, max. We keep track of the current min as well, because when we need to handle situations where our next value is negative, Whatever value is the smallest negative could become the max prod if the next value in the array is a negative number. So a negative times a negative is of course a positive, so in a contiguous array, we can easily flip from 0 to hero, essentially. If the next value was another negative, those negatives are going to allow us to be able to possibly even get a bigger number than we had before. And so the reason that we do the parallel assignment, so if I separated these variables and put them in different lines, so if I took this like current min value and set it equal to this, and then on the next line, the next line I did current max instead and set it equal, that would not work. It would not be the same thing. What would happen is we would lose the integrity of the original values that we currently have saved as our current max and current min, and we'd be using the new current min value for our current max calculation instead. So this current min would be calculated on this line, and then this current min would change, so this would not be the same thing. By setting the variables on the same line, we complete the full calculation using our original values before setting our variables. And then the last thing that we're going to do before we return is we're going to set our max prod. So max prod is just going to equal the max of max prod and the current max. And then all we're going to do next is just return max prod. Save that. And then I have a couple different statements right here. And if we run it, we get our answers. And so as you can see here, I did add a -1. This value up to this point equals -48 as the minimum. It equals -48. So if I took a -1 here and multiplied it by -48, this value down here is going to be 48, which would be our maximum. So we're really just one away of getting a huge big maximum number if we had a negative as our next number. But unfortunately we didn't, so our maximum of this original was only 6. That's all I got for you guys today. I really hope that helped you understand a little bit more about how to solve the max product subarray problem. If it did, please subscribe to my channel and like this video so you can see more videos like this. I'm going to be continuing the Blind 75 series so that you guys can hopefully pass your next interview. Until next time, I hope you have a great rest of your day. Happy coding!